So this was a quiz about special quadrilaterals, but also about writing equations of lines. Let's start with the quadrilaterals. Now keep in mind that we were supposed to memorize this set of information right here. So let's pretend that we have everything on this paper memorized, and to the extent that that is not true, you need to pause the screen from time to time and write this information down and memorize it. Okay, for each quadrilateral, write the name that best describes it. Trust the markings, not what the shape looks like. Use the answer bank. There will be one word that doesn't get used. Okay, so the first one has all sides marked congruent. So we know that that is a rhombus. All right, a rhombus has 4 congruent sides. All right, this one has 2 pairs of congruent sides that are consecutive. They are touching. The congruent sides are touching. That is a kite. All right, when you have consecutive sides congruent, that makes a kite. All right, one pair of parallel sides. That's what these arrows mean. One pair of parallel sides, that is a trapezoid. All right, exactly one pair of parallel sides. Now, here we have one pair of parallel sides again, but the non-parallel sides are congruent. That is going to be your isosceles trapezoid, where you have one pair of parallel sides, but the non-parallel sides are congruent. So, isosceles trapezoid. Four right angles. That is a rectangle. All right, the definition of a rectangle is 4 right angles. Kabam. And opposite sides parallel. That is the definition of a parallelogram. Opposite sides parallel. All right. Circle all quadrilaterals that have the given property. These are just properties, not definitions, so you might circle more than one. So now we're talking properties. So up until now, I've been staring at the yellow boxes, which represent my definitions. Like a rhombus has 4 congruent sides. Boom, that's in a yellow box because that's the definition. But now I'm going to be looking at the red statements because these are the properties. For example, one of the properties of a rhombus is that the diagonals are perpendicular. And we see that squares here coming in from the side because a square is both a rhombus and a rectangle, so it shares all of these properties. So if they were to say something about diagonals perpendicular, that would be true for a rhombus and a square. They overlap. But also, I'd look over here at Mr. Kite. The diagonals of a kite are also perpendicular. So that's the kind of thing we're going to be doing. All right. Circle all quadrilaterals in this list that must have 4 right angles. Well, that is the definition of a rectangle. So I'm definitely going to circle that. 4 right angles, that's a rectangle for sure. Okay, however, a square is a rhombus and a rectangle. So a square is also a rectangle. So a square has to have 4 right angles as well. So I'm going to circle rectangle and square. Circle all quadrilaterals that must have exactly 1 pair of congruent sides. Well, they're talking about, well, okay, 1 pair of congruent sides. The only one that has that happening is an isosceles trapezoid. 1 pair of congruent sides. A parallelogram has 2 pairs of congruent sides, and so does a kite. A trapezoid doesn't have to have any congruent sides. So it has to be isosceles trapezoid. That's the only one. All right, I think that's it for the quadrilaterals. Now, let's move on to the main thing. The rest of this video will be about finding equations of lines. And we will be leaning heavily on the model y equals mx plus b, where we know that the m here is the slope, and the b part is the y-intercept. Okay, so write the equation of a vertical line that goes through this point. All right, well, this is a special case. As soon as I see vertical line, write a vertical line, which looks like this, in case you don't know what the word vertical means. Vertical lines always have a simple equation of x equals a number. And since it's x, then I know it's going to be the x value. So x equals 9. I don't know why I wrote it over there when I clearly am supposed to write it on the line. So that was a little extra. But that's okay. Write the equation of the line that goes through both of these points. Now, normally I would say, hey guys, let's write a whole thing, and I have a little graphic organizer that I like to do where I find the slope and I find the y-intercept and I write the equation. But I'm thinking ahead, and I see this is going to be a special case. See how the y values are the same? All right? Without even thinking about it, that tells me that this is either going to be horizontal or vertical. If the x values are the same, that means something. If the y values are the same, that means something. Imagine graphing this, okay? Like, what if we did just a little basic graph? Might be the easiest thing to do. 7, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, right? So 7, 2 would be like right here. And then 1, 2 would be like right here. So you see what's happening. This is forming a horizontal line. Okay, horizontal lines have the equation y equals something. I'm doing it again. Horizontal lines have the equation y equals something. And clearly y equals 2 because the y values are 2. So that is the answer. Now, let's say if you didn't notice the thing about the y values being the same, and you just said to yourself, well, I know I'm going to need the slope, and the slope is, maybe I'll write that formula here. The slope is y2 minus y1 over x2 minus x1. Let's say if you did this. Then you would immediately run into 2 minus 2 over 1 minus 7. But that would be 0 over negative 6. All right, which means that the slope is 0. Okay, so if the slope is 0, again, you know it's going to be a horizontal line, which leads you to y equals 2. Okay, anyway, let's move on. There's more I could say, but I think I'm going to lose you if I explain any further. Write the equation of any line that is perpendicular to this line. Okay, so when they say perpendicular, they are indirectly giving us the slope. All right, so focus on this. Here's the slope of this particular line. The y-intercept is irrelevant, all right? If they say parallel or perpendicular, all we care about is the slope. So scribble out the other thing so you don't accidentally use it. It's not relevant to the problem. Okay, write the equation of any line that's perpendicular to this. Well, remember y equals mx plus b. The key is the slope, the m part. If lines are perpendicular, their slopes are opposite and reciprocal. The reciprocal, that means you have to turn this upside down. So that would be like 5/2. Okay, that's reciprocal. But it also has to be opposite, meaning the opposite sign. So if this is positive, then this is negative. Okay, so perpendicular lines have slopes that are opposite and reciprocal like this. So I can write any equation that has this slope. So I can write y equals negative 5/2x plus, and I can put any number here that I want. Okay, so I could put 7. It doesn't matter. Technically, I could even put that number that I took out. I could put 9 if I wanted to. There's nothing wrong with that. So you could put any number here you want. But that's one answer. Moving on. Write the equation of the line graphed here. Well, this is a vertical line. Vertical lines always have the equation x equals something. And this vertical line is at 1, 2, 3, 4. So x equals 4. All right, not much to that. Getting a little bit more interesting on this one. The slope, okay, we're doing y equals mx plus b, right? So we need the slope first, the m. Here's a point on the line. Here's another point on the line. You know, I think I'm going to just zoom way in to talk about this. Because rise over run, people, that's what we got to talk about. As I move from one point to the other, it's like there's the rise and there's the run. Okay, this is 1 and this is 2. Now, some people like to say, well, I went down 1, so you could think of this as negative 1. And I went right 2, so that's positive 2. And that's fine. That's one way to think about it if you want to. So remember, the slope is rise over run. So that would make this negative 1/2. But sometimes students make mistakes with the which one is negative and which one is positive. So what I like to do is zoom out and just look at the picture as excuse me, as a whole. Can you see that the line is going downhill from left to right? That tells you that the slope is negative. So just no matter what you do with the little rise and run, make sure that your slope is negative in the end. So this will be y equals negative 1/2 x. All right, then next comes the y-intercept, the b part. All right, do you guys know that the y-intercept is the point where the line touches the y-axis? So this point right here, this is where the line crosses over the y-axis. So this is the y-intercept, which is -1, actually, because it's down 1 from the origin. So that's why I'm going to put a -1 on the end of this thing. And that's it for that problem. Moving on to number 9. Okay, write the equation of the line that has this slope and goes through this point. All right, so here's where I am going to do my little graphic organizer thing. Okay, so my graphic organizer works like this. I'm going to start with the slope, figure that out, and then I'm going to find the y-intercept. Okay, let me just try that again. I couldn't decide if I wanted to do a hyphen or go straight to the I, and I kind of mixed both of them together, and it wasn't working. Intercept. And then I will write the final answer, which is the equation. Knowing that the equation goes y equals mx plus b. So our goal is to just fill in these two boxes. So let's start with the slope. Sometimes we have to find it, but sometimes they just give it to us. So I think this is one of the times where they just gave it to us, right? I don't know why I'm changing colors mid-problem, but they told us that the slope was -3/4. So this time they just flat out gave it to us. Which means that's going to go right here, -3/4. So all we really have to do is find the y-intercept, and that goes here. So when we're finding the y-intercept, in the back of our mind, we're thinking y equals mx plus b. We're just going to plug in y, m, and x. The y value, well, this is x and this is y. So the y value is -5. So that's why I start off with -5 equals. The m is what we just found, -3/4. And then the x is 12. And then plus b. Now I can do this in my head because 4 goes into 12 3 times. And then 3 times -3 is -9. So this is going to be -9. So I know it's going to be -5 is equal to -9 plus b. But a couple of you are thrown by that, and you will not follow that. So you will use your calculator. So -3/4 times 12. Here's what you do if you didn't like the last thing I did. -3/4 times 12. All right, your calculator is amazing, and you can use it if you need it. Anyway, to get b by itself, we need to add 9 to both sides. So that will give us 4 is equal to b. And that's it. So we know that b is 4, so that's going to go right there. Okay, and that's the answer. So the answer is y equals -3/4 x plus 4. All right, moving on. Write the equation of the line that goes through these 2 points. Great, so I'm going to use my graphic organizer again, because it works great. So I'm going to do slope right here, and then I'll do y-intercept in the middle, and then I will write the equation. Okay, and the equation always works like this. Y equals mx plus b, where we're just trying to fill in the m and the b. Starting with the slope. The slope, the equation for slope, so I'm going to squeeze in right here. Slope is y2 minus y1 over x2 minus x1. So we've got these 2 points, so that's what I am about to do. All right, so of course this is x and y and x and y. So 5 minus -1. All right, listen to what I just said. It's not 5 minus 1. It's 5 minus negative 1. Do you hear the double negative there? 5 minus negative 1. How do you handle subtracting a negative number? You turn it into addition. So it's really going to be 5 plus 1. And then 8 minus 6. So 8 minus 6. So the slope is going to be 6 over 2. And 6 over 2 is 3. 6 divided by 2 is 3. Another way to say that. So we now know the slope. So that's what will go in this box. Time for the y-intercept. Remember, we are thinking y equals mx plus b. We just need to fill in y, m, and x. So just pick any of these points. Doesn't matter which. I think I'm going to use the first one. So the y value is negative 1. So I will have negative 1 equals. The m is 3 that we just found. The x is 6. And then plus b. So we have negative 1 is equal to 18 plus b. And then we have to subtract 18 from both sides. So that gives us negative 19 is equal to b. All right, so the negative 19 goes right here. For your final answer, do not put plus negative 19. Just write y equals 3x minus 19. Great, great, great. Okay, well, this is the same exact thing. So let's just rinse and repeat. All right, let us use my amazing graphic organizer again. Okay, slope, y-intercept, and equation. So y equals something x plus something. Okay, so we learned on the previous problem that the slope is y minus y over x minus x. So we're going to do 57 minus 7 over 24 minus 4. All right, so that means we have 50 over 20, which reduces down to 5 over 2. So that's the slope. Okay, time to find the y-intercept. And in the back of our minds, we're thinking y equals mx plus b. We just need to fill in y, m, and x. We need to pick one of these points. Obviously, we're going to pick this one with the smaller numbers. That's the only reason. Starting with the y value, so we will lead with the 7. So we will have 7 equals. And then m is our slope. So in comes the 5 over 2. And then x is 4. And then plus b. So I can do this in my head. 2 goes into 4 twice. 2 times 5 is 10. So I know this will be 7 is equal to 10 plus b. But if you're like, what? What did he just do? Then use your calculator. 5 over 2 times 4. 5 divided by 2 times 4. No shame in this calculator game. Subtract 10 from both sides. So this is negative 3 is equal to b. So that will go here. Again, do not put plus negative as part of your answer. Please just write y equals 5 over 2 x minus 3. Don't put plus negative 3. All right, what's next? Write the equation of the line that's parallel to this, but goes through this point. Okay, parallel lines have the same slope. Okay, that's the key. Same slope. All right, and the slope is right here. The y-intercept is irrelevant, so I'm going to scribble that out. So when I do my little graphic organizer thing, like I do, I'm just going to use this slope. So here I go, slope, y-intercept, equation. And the equation goes y equals something x plus something. Great, but the slope will be 3/4 because parallel lines have the same slope. So the slope is 3/4. When we do the y-intercept, in our minds we are thinking y equals mx plus b. Let's start with the y. This is the x value and this is the y value. So I'm going to start with 1 equals, and then the m is the 3/4. Okay, and then the x is -12, and then plus b. Now, some of you can do this in your head. 4 goes into -12, -3 times. -3 times 3 is -9. So this is going to be 1 equals -9 plus b. But if you cannot easily follow what I just did, put it in your calculator. 3/4 times -12. Just put it in your calculator. 3/4 times -12. A calculator is truly a thing of beauty. Now we will have to add 9 to both sides, which will give us 10. So we now have the slope and the y-intercept. All right, the slope goes here, and the y-intercept goes here. Kabam! Moving on. Perpendicular. All right, so perpendicular lines do not have the same slope. When you see perpendicular, you should be thinking slope is opposite and reciprocal. All right, and here's the slope right here. Put a little box around that. So when we make our chart in a minute, our little graphic organizer, it should be opposite and reciprocal. The slope we're going to use will be opposite and reciprocal. The y-intercept is irrelevant. Scribble it out. We're just talking about the slope, nothing else. Okay, so anyway, slope y-intercept equation. And the equation goes y equals something x plus something. All right, so let's start with what do I mean by opposite and reciprocal? Well, reciprocal means you turn that fraction upside down. So since I see 2/3, the reciprocal is going to be 3/2. So that's what I mean by reciprocal. What do I mean by opposite? Well, opposite means the opposite sign. So since this slope is negative, then this slope will be positive. So we're going to use the slope of positive 3 over 2 because it is opposite and reciprocal of the slope of this line, which is perpendicular. So we know the slope is 3 over 2, and that goes right here in this box. Now it's time to find the y-intercept. As we contemplate the y-intercept, we are thinking about y equals mx plus b. This is x and this is y. So starting with y means starting with 7. So 7 equals. Then it's time for the m, which is 3 over 2. So 3 over 2. And then next is x. X is 6. And then plus b. And b is the y-intercept. You might be able to do this in your head. 2 goes into 6 3 times. 3 times 3 is 9. So this is going to be 7 is equal to 9 plus b. If that bothers you in any way, use your calculator. 3 over 2 times 6. So 3 over 2 times 6. That is 9, like I said. Then we will subtract 9 from both sides and get negative 2 equals b. So that is the y-intercept, which will go right here. Do not put plus negative 2. For your final answer, you need to put y equals 3 over 2x minus 2. Do not ever put plus negative. It's tacky. You show yourself as an amateur if you do that. Number 14. Line L is parallel to the line graphed here. Let me just pause there. As soon as I see the word parallel, before I go any further, what pops into my mind is same slope. All right, parallel lines have the same slope. Okay, and goes through this point. So find the equation of line L. All right, I might have to use a smaller ink so I can fit my chart in here. So I don't have the full space that I normally would have. So I'm going to write a little smaller. But that's what I'm going to do. So I'm going to do slope, y-intercept, equation. And the equation goes y equals something, x plus something, where I just need to fill in the slope and the y-intercept. Let's start with the slope. The slope is going to be the same slope as this parallel line right here. So what is the slope of this line? Let's look at a couple of points on the line. So there's a point here on the line, there's a point here. Slope is rise over run. So let me go back to a thicker ink for a second. So here's the rise, and here is the run. So see how that is up 2 and over 1. All right, so that tells us that the slope here, rise over run, that's vertical, and then over horizontal. That would be 2 over 1. But 2 over 1 is just 2. So the slope is 2. So that's what goes right here. Now do not get fooled. We are not finding the equation of this line. Line L is parallel to this line. It's not this line. I'm mentioning that because you might be tempted to look at the y-intercept right here and see that the y-intercept of this line is 4. So you might think that this will be a 4. But no, this is not line L. This is parallel to line L. Parallel lines do not have to have the same slope. They won't have the same slope. All right, because a parallel line would be like this. All right, a parallel line is going to have a different y-intercept. So we have to figure out what that y-intercept is. And so we're just going to do the process like normal from here. Okay. So as always, we're thinking y equals mx plus b. And this is x and this is y. So for y, we're going to go 8. And then for m, that's going to be 2. And then for x, that is 10. And then plus b. So that's 8 equals 20 plus b. And then we subtract 20 from both sides, and we get negative 12. And that's b. So the negative 12 goes right here. And one more time, let me say to you, please do not put plus negative 12. Just write y equals 2x minus 12, like that. Notice that the y-intercept is negative 12. It is not 4. So, aren't you glad we didn't use the 4? It's a parallel line. It's not the same line.